Okay, so we're going to... the same box from the gentleman from Holmfirth as in Last and Summer Wine. We've got another of Nora Batty's radios here. And this time it's an Audioline 341. This is from one of his work colleagues. And it's got a naughty switch on the back, and he reckons it's probably got a Roger bleep board or something else. But we'll soon find out what it has got. He doesn't want to spend a fortune on it, but on the other hand, our pricing structure is so ridiculous. I think we reviewed it in 1994 last. Why can't I see a screwdriver? Is there any reason for that? Yeah, well, I don't know what's happened between yesterday and today, but the normal screwdriver doesn't appear to be around. Perhaps we can reuse this ridiculously large one. Once again, I'll just take out the speaker lid screws, because my logic is if I take all the screws out, it won't want anything doing, and if I only take the speaker lid screws out, nothing will want doing. Is that right? No, it'll want the capacitors and all that, but I'll just take these out initially. There's a Midland as well in the box, and I should have done that next. But because I've got the service manual out, it seemed sensible to... Oh, good grief, what's this crap? Oh, it's a 5-tone one, isn't it? And into the vertical filing cabinet with it. Right. So once again, we need to change that capacitor, that capacitor, that capacitor. That one's been changed, so it's already had that problem and it's been dealt with. I'm going to change it again because I don't know when it was changed, and I've also seen in the past that some people have been daft enough to put second-hand capacitors in recovered off a scrap chassis. So I don't want to let this go if that capacitor is of a unknown. So I've just unsold the switch, which is for that Roger bleep. It's also been 80 channeled, has it? Yes, it has. So that's all got to come out. Disgraceful. Yeah, so it's had the piggyback chip in to turn it into an illegal radio. I don't know what it's all about because they never work properly. I'm not going to cut that out yet. I'll just demonstrate the radio not working well with that modification in place, if it still works. Lots of the time, unfortunately, it kills the proper phase lock loop chip, and those are now, well, we'll say they're unobtainable because I can get some from Brazil. They need me to buy 100 at something like £26 each, you know, so it's not going to happen, is it? But it's a shame that a lot of these sets have been ruined by silliness. You know, if you want to use CPT channels, well, buy a set with CPT channels, you know. So I won't disturb any of that yet. We'll just get this. I'll just get this sorted out so that the radio is going to work as it should do, and then we'll come back to the video and we'll run through it as it's working at the moment. Okay, so I've got rid of that. I've just checked the wiring with one of our scrap chassis, and so we've got rid of that Roger bleep. As I said, I was going to keep the naughty 80 channel modification intact at this point, just so we can test the radio. So this is an Audioline. So we'll write it on there, and it's is it 341 when it's the big one? Yes. Right, so plug the test equipment in. We're using our own standard replacement mic, and with crocodile clipping. I'm not using his one off his other set, his mic, because I'd rather listen to one of these. We've got the front coming away, Okay, switch power supply on. So let's come on channel 19. We'll need to just plug our test equipment speaker in. External speaker there. So we want that up, that down. And let's see what happens when we press transmit. So, well, I'll go on the lower scale because it's not actually doing that much power unless I've got it in low power. Oh, it is. It's me. Where are we with this? Oh, when it's in, it's 4 watts, right. So it's actually doing 4.5 watts. So that will need to come down. And on low power, it should be doing 0.4. And it's doing 3 watts. Ridiculous. So let's see where we are frequency-wise. So it should be 27,79125. So it's off frequency. That is just acceptable. I would say 27,79085 is just acceptable. If that's all we could get, then that could just go. But it might be being affected by the illegal modification. And if I press the tone switch, I think that's going to make it go into the CPT set of channels, which would be illegal for this to happen on this kind of set. Oh, I'm right, and it's off frequency on there. Okay. So that's all we need to demonstrate with that. Let's see what the deviation is. 1 2 1 2 1 2 1 2. We haven't got the mod meter on. Why haven't we? 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. I'll just put our monitor receiver in. Testing 1 2, testing 1 2. There may be a cut track where they've done that Roger bleep, so I may have failed to have spotted that. So deviation, we still don't know. So on receive, let's see what we're doing. So 27,79125 on the signal generator. When I find it. And I'm going to have it low so that it matches the frequency on which it's working, so we're not testing the receive on frequency when in fact it's off frequency. So I've now set that to match what it's transmitting on. So we'll put the cyanide meter on and let's pop that onto the screen and let's see how well it's receiving. And the answer is, have I got the RF? It's so bad. No, it's so bad I'm checking the RF gain. And this is what I've always said. Legality aside, these modifications always end up with it working rubbish. Just about 12 dB there, and it's 3 microvolts for 12 dB cyanide. So let's see what we get for 10. There's 10. It is 2.7 microvolts for 10 dB cyanide. And if we can get 20, let's have a look. It is, check which scale I'm on. I'll tell you what, I changed scales. That wasn't easy. we're right between scales. It's actually it's 10 microvolts for 20 dB. Absolutely atrocious. Now, I've sent Mr. Chippy out on a scratchy corner test. We wouldn't hear him at scratchy corner on this set as it is. He'd probably come out the other end. We'd probably hear him at Wilsford level crossing, and then it would peter out again. So it's absolutely atrocious. Transmit's over the top. We can deal with that. You know, so it's doing 4.5 watts. It doesn't mean that you get 20% more range. You don't. It makes no difference. It makes very little difference. I probably said yesterday I was talking to an amateur radio. I don't normally use 2 meters, but he was on a handheld in Wales, and he was 250 miles away, and I was doing 10 watts, and he was doing 5 watts. You know, and there you go. I'm not saying you can necessarily do that on CB, but you can. We certainly regularly get 35 miles between mobile and base in certain directions. Not all the directions are as good in this here from here. So there you go. Right. So what we're going to do, we'll get rid of all this illegal rubbish and see whether we can get this back to factory standard, which will mean rewiring this front panel. I'm glad they've done it on the tone switch and not the PA switch. And if you remember before, when we've come up against this, it follows the resistor colour code, the wiring just here, and it's so it's black, brown, red, orange, yellow, green, blue, and so on. So we'll just get that wired back. Pause the video. Right, Mr. Chippy's taken the piggyback phase lock loop chip out. What he's done is to cut it with sharp cutters. So you cut the pins off and then individually unsolder each of the pins. What we don't want to do is to apply much heat to this phase lock loop chip and, you know, ruin it. It's so easy to do that. So we'll now plug it all back in. I haven't looked as to the reason behind no audio yet on transmit. I'll concentrate on getting the thing to work. And I'll put the wiring back, black, brown, red, orange, yellow, blue, grey, violet, grey and white in that order, and there's been a cut track which we've bridged with a wire. So there's probably going to be something on this side. And what's that resistor? Is that resistor supposed to be there? I don't think it is. Let's look at our Uniden one. We have to take the bottom off our Uniden one to see whether it looks burnt out. To be honest, that resistor, it's got a big black mark. Now we've changed the two 220 microfarad capacitors. The blue one, which had been changed before in the phase lock loop section, we measured it and it's reading all right, but it's a 10 volt one, which is fine. But nobody would put in a 10 volt one in reality, would they, today? So it's got to have been taken off a scrap chassis from something else. So we don't know its origin, we don't know its age, and for the fact they are 16 pence, it was prudent to change it. The other 220 microfarad one read 56 microfarads. So no, that resistor shouldn't be there. So we'll get rid of that. But again, this looks like it's been recovered out of a set. So whether or not it's been taken off the board is probable. I wonder if it goes between there and there. Let's have a look. So got a resistor there, but we haven't got resistor 85. So I reckon that could be resistor 85. So I'm going to have to test that as to whether we put that back or put a new one in. So let's see what resistor 85 should be. Resistor 85 should be 68 ohms. Oh, it's working fine. 69 ohms, that'll do nicely. So although it looks tarnished, it's had generated some heat on it at some time, but anyway, it works. So I'm not sure why they've done that, but all part of their daft modification. There aren't any surgical scissors on here, so we'll use the side cutters with care to put it back. At the end of the day, if we've got to change it, we've got to change it, but I'll try not to chop it in half. This may be in 2 days. I have a limit to what time I can put into these. We're only supposed to be doing one a week, and I'm kind of doing this the next day. Yeah, that's definitely through. Okay. Now, do they cut any tracks on these? They do, yeah. So we've got a cut track. I never know, because they do these things different ways, different people, and you know, you fire it up and you think you've covered everything, and lo and behold, you haven't. Now, I won't be doing this with just a solder blob. We'll just pop a bit of wire on there as well. Just tin both sides of the track. I should have kept back a bit of that wire I just pulled out, shouldn't I? Put that across, having tinned it. Cut that off. And hopefully Bob's your uncle. Right, we'll plug it back in. And see whether it's nearer being on frequency, if it works at all. Power supply back on. So we're lit up. So we've changed that capacitor, that capacitor, that capacitor, and that capacitor. 470, 470, 220, 220. And we've used 25 volt ones, and these are Nikon, so they're the highest quality. So let's see whether we've got transmit. Helps if we plug in the test equipment. And we have, oh good grief, it's now doing 5 watts. However, it's off frequency, so something's happened. So I've just spotted we've got a cut track there. So I've removed a link between there and there, and we've got a cut track there. Now that one we should just be able to put a solder blob on. May actually get somewhere now. No, there must be something else happening as well. I've had the isopropyl alcohol on it. Did I say that right? But I have. And there's another cut track. I think we'll put a bit of wire on that one as well. It's so easy to spend 90 minutes doing this. Make sure we're off. Good. Let's see whether that can make the VCO work. Power it up. Hope the isopropyl alcohol's dried. My crocodile clips have come off. Get the meter back somewhere near. Ah, we've got better. We've gone away from a minus voltage. Yay! Oh, I've got we're on a minus voltage simply because I've got the cods wrong. There we go. That sounds better, doesn't it? You can hear the signal generator as well. So let's remind ourselves of what we're supposed to be doing, and it's supposed to be 3.5 volts on channel 40 on transmit. I'll do me, and then I've gone and done it on channel 20, so I'll have to reset that. Okay, and channel 1, we'll just check it's in lock, it is transmitting, that's fine. Good. Well, I'm glad to get that back to the land of the living. You're not looking at the power meter, you're looking at the frequency. So let's go back to channel 20. 2779095. So I said I wanted to be better than an 085. It's a little lower than I would like, but it's in spec, and that's what's important. So the only way to change the frequency on these is to change the crystal, and we don't want to do that because we don't want to incur any costs, because the customer wants to keep it to a minimum. Well, I'm gonna still have to go through the transmitter because it's going to have probably been tuned as a compromise between the 80 channels it was being made to do. So we're not going to do that one till we do the receive, They have you do it with an oscilloscope. I do it with the synad meter. So we'll just go through these. Just get them peaked. 4.8 watts. 4.9 watts. I can't remember whether that's transmit or receive. See, I only did one yesterday, didn't I? So don't expect me to remember. So we're on that one, and it is on transmit 16, 15, 14, 13, 12, 10, 14, 13, yeah. Yeah. And then we just need to tune down for the correct power on that one. There we go. So on low power, instead of it swinging right across to silly power, 400 milliwatts, so that's that done. Back to higher power, doing full 4 watts. So what does the meter read? I think the meter could be stuck. Just check. Yeah. We'll just see whether it's the bearing, and I'll just remove the bit of tape. What I don't want to do is to incur costs stripping down meters. The customer does want to keep this one down, and it's, you know, expensive enough when you start spending all this time taking out illegal modifications. Capacitors are neither here nor there. But you see, at least it's on frequency now, and it wasn't before. You would think, wouldn't you, that when people have had these things modified, wouldn't they say to the person who's done it, but the radio works rubbish now? What was the answer? Oh, well, it's a bit of a compromise. So it might be possible that all that's up is it's a bit tight on that bearing. Might need a precision screwdriver, which we haven't got on this bench. Don't think we want to use the trimming tools for that. So we might get the phosphor bronze one in. On the other hand, we won't. Now I'll have to see what Mr. Chippy's got on his bench, but worry about the meter later. So we've got transmit right, it's on frequency, we've got no deviation. 1 2 1 2, testing 1 2, wallow. Or have we? Wallow. 1 2 1 2 1 2. I don't think we have. Testing 1 2, testing 1 2 1 2. Just see whether we've got any audio if I touch the deviation control. We have 1 2 1 2. Wallow, wallow, 1 2. One two 1 2. So you can hear we've got a click when we touch the deviation control. The radio is capable. So they might have cut a track. Now these have mic gain. I'll just check that's up. It is up. Yeah, I think we'll have to come back to that as well. So, forgetting the deviation for now, let's have a look at the receiver. So first of all, I want to make sure that the detector is set. So we'll go to the oscilloscope, turn the bench light off. Oh my goodness, that's dreadfully strangled. I can't turn it up any more than that. So I recall this is the detector coil. Yeah, we've got another problem. Is it working on PA? Testing 1, 2. So we've got no audio on PA. Anyway, we'll go through the tuning because we can at least do that. There's still quite a number of issues. So we'll set that to about 4 dB synad. We'll go through the front end. Let's bring some life back into this deficit post receiver. Well, we haven't got anywhere with that one. We've not gained anything with that one. Not got anywhere with that one. No improvement with that one. Let's go on to the IF ones. Oh, did I hear it just go a bit louder then? Anyway, we'll just put a bit more signal on for these IF ones. Let's just read off what we've got for 12 dB, and we have got 1.5 microvolts, which is atrocious. So we've got something not right. Yeah. So I'll look into that, and I think we'll be doing that another day. Okay, so the next day, what I've done, I'll just switch the other camera on. Probably. The next day, I have changed some capacitors in the receive line. So, one of them's been changed before, and again I think they've used an old one off a scrap chassis, which is ridiculous. So we've got 10 microfarads for capacitor 5. We've got 4.7 microfarads for capacitor 2. So that's capacitor 5, capacitor 2. And then I've looked at this part of the circuit diagram. Any leakage, and we could have losses in the receiver, you see, this is what I'm looking at. Capacitor 18, 1 microfarad. Is there in the IF section, and then capacitor 16, which is next to that one I'd changed previously, and of course our favourite 221 is there. Did I tell you it tested out as 55 microfarads instead of 221? We tested that one. So straight away I now have 1 microvolt for 12 decibel synad. So I'll just switch picture in picture on. So if I just adjust my, well, just about there, and I haven't readjusted the receive. Now, one thing I hadn't done was to check that this injection level from the synthesizer, I needed to check that. So we have got an improvement there as well. We still need to sort out why the audio's being strangled, but what we now have is 0.5. Oh no, we have not. Wish we had. What we now have is 1.5 microvolts for 12 decibel cyanide. See what we're supposed to have as a limit. I mean, that's still rubbish, isn't it? Oh, it's supposed to be 1 microvolt for 10. So there we are at 10. So we're kind of 1.45. So still need to gain something out of it, but it's better than 3. So I'm just going to see why we've got this strangled audio, and then we'll go back on to tuning the receiver. Okay, so what I've discovered and fixed it, normal volume, we've now got transmitted audio. I'll just put the camera onto that. I need to set the deviation, 1, 2, 1, 2, wallow. So we have got deviation there. Let's just put the monitor receiver on. Testing 1, 2, testing 1, 2. So what it was is, for some reason, when I took my sample set apart, I took the mic socket out so you can actually see it, we've got the black wire to there, and on this set the black wire was on there, so that's cleared that fault in one fell swoop, as they say. So I'll just pop mine back together. Don't think we'll bother tightening that up in case I need to use it again. That on loosely. So that's cleared 2 faults in one fell swoop, which is great. So we'll get Mr. Chippy's toothbrush on this and the isopropyl alcohol. I'll turn the power off. I think we're on the home territory now. It's really starting to come together. So really, we've changed 8 capacitors. So there, Roger Bleep must have had to work some strange way, but they must have had receive. I think it's a mistake. I think they've had garbled receive since the modification has taken place. Not necessarily the 80 channel modification, but the Roger Bleep modification. I actually think it's been installed wrongly. Anyway, it's now installed in my dustbin. So once I can actually see the quality of the soldering, we can decide whether it's okay or whether if it needs redoing. I think it's alright. I can't see anything across any tracks. No, we can put that back together safely. We may get a little bit of cyanide back with the audio not being strangled. Now, where did I put the screws for this? The screws, the nut and the washer. I'll tighten this up with a spanner later because I had to do that on Mr. Chippy's bench. I just want to get this done with. Someone's had this out, you know, the threads aren't as, in fact that's going on cross-threaded. Let's just try and put it on the other way. all right at that point. Anyway, I'll get the spanner on that. Now I'll put the power back on, put the mic back in. We'll just go through this tuning once again. Put that to 4 dB. That's not as sharp as I would expect it to be, and it makes me wonder if there's an anomaly around there. Put more signal on for these IFs. I don't know whether we're getting a capacitive effect without the lid. Just put the lid on loosely on the bottom. Now that's made all the difference. Once again, we'll go back to 4 dB. Just check that. Go up another scale. And let's see what sensitivity we've got now. So there's 12 dB, it's now doing 0.82 microvolts for 12 decibel, and for 10 decibel it's now doing 0.7, which is exactly what we'd expect. So the manual, as ever, I think it said 0.5 is what they'd like it to be, and the limit spec's 10 is 1, so we're now well in. Good. Well, that's between one thing and another. Yeah, when you're tuning the receiver, do put the bottom lid on because you've got a capacitive effect, if I said that right. So changing those 4 capacitors has made all the difference. Made a bit of difference by getting the audio back as it should be. I'm just going to we'll just check, we'll put it onto S9. We'll just check with the oscilloscope and just see whether that detector is still correct. Because when we did it yesterday, we didn't have the audio, which would have been best, and it was miles out. No, that was still spot on. So now I think we've still got the anomaly with the meter, but we just set up the deviation for transmit. Wallow. See where we are with the little meter oscillator. 1 to while low. That's it, spot on. So it's now 2.2 to 2.5. We'll do the squelch, I think, next. So with the set on full squelch, I want the squelch to come in at 100 microvolts. They want it to be about 300 microvolts. I want it to be 100 microvolts. We couldn't quite achieve that. No, it's 1,000 microvolts they want it for, isn't it? Oh, yeah. Oh, they want the meter to be 100 microvolts, which is what we'd set it to. Squelch sensitivity type, yeah, they want it to be 1,000. Well, we want it to be 100. So that's where we deviate from the manual. So we've got the... I'll put this on the attenuator, then you can see. So we've got 30 microvolts. We've parked it at. I've got the squelch on full on the radio. So when I turn that to 100 microvolts, I want the squelch to come in. And it does. So it doesn't need adjusting. But if it did need adjusting, the squelch preset is just there. We're not going to touch that. So we're going to go to the sensitive end. We'll turn the signal generator to standby. Turn the squelch down to threshold on the radio. Set threshold. Switch the signal generator on. It's parked at 0.3 of a microvolt. Let's see when it comes in. Oh, that's not very good. 2 microvolts. That won't do scratchy corner very well. Let's try that again. We'll set it up really carefully on the radio. You can't always do this in a car. So really have been careful there. Once again, switch the signal generator on. So we now, squelch is coming in at 0.75 microvolts and leaving it 0.5, which is fine. So like with the Uniden 100 we did, you've really got to be careful with the squelch control to have it where you want it. So it's always possible this radio could benefit from other capacitors being changed, but at the moment it does work properly. It's doing a full 4 watts, and I'm clearing my throat. Vicar's come down with COVID, so I did myself a test yesterday, and it turns out I'm still alive, so there you go. So we just need to see if we can get a precision screwdriver on that meter. I'm going to disappear off and do one of the parishioners' shopping jobs, and I'll be back this afternoon. Right, so we've put the mic socket back on. I've backed off one of the bearing screws on the meter in the hope that it unjams it. I'll tell you what I think we have. So we put 100 microvolts on the signal meter. Performing a bit funny. Is it a dirty preset? Yeah. So there we have S9, and then on transmit, just turn that off. I've nearly swept all the screws on the floor. I've just got them out to put the bottom case on. So on transmit, we'll just turn that well down. Centre of the red zone. Then on low power, just a bit. That's restored the tone switch, which had previously selected the CPT set of channels, which, as I've said, it's not that the channels in themselves are illegal, it's that you can't fit them to a 2781 radio. So, I think we're there. Yes, I think we're there. I'll just check how on frequency it is for final time. 79106. So yeah, it's well within spec. Not quite spot on, but that's how these are. So if he looks on eBay, he may be able to find a knob. Trouble is, when we buy chassis, and somebody else has already sold the knobs from them. So that has got a heap of Sierra Hotel 1 Tango back into working order. And with what had happened round that microphone socket, I honestly can't think how it was working for the person since they put that Roger bleep in, because it was strangling the audio on receive, and there was no transmitted audio because of the earth in the wrong place. So whether or not it was a 5-tone Roger bleep installation failure, I don't know. Just check, just for the giggles, whether we've got one of these going to earth, not that one. What am I doing? Helps if you put it on ohms, doesn't it? Let's go back to the start. So that one's negative. So it really doesn't matter, but you know, I may as well. Then if he's got 5 CB sets on at once, all in phase, they won't sound funny. And after all that, let's hope the speaker works. I'll just apply some hot glue to the front where it's come away. I'm not going to start doing repairs. I'm trying to switch it on and knowing full well that the power isn't connected. We'll unplug the extension speaker. Hooray! Very good. Right, we'll plug in the aerial instead of the test equipment. I'll even put some screws in the case. Now to this same batch, there's a Midland. I think it's one of those small ones, like a 099, something like that. And I think it's in its box. He's also sent along some voltage droppers to check out. And he's also sent me, as a bit of a part chop, a Bremy power supply, which we'll be doing a video on and retaining. Right, so we're on the aerial now. Of course, I would, if I borrowed the power lead off his other set, we wouldn't have to play with the crocodile clips, would we? Or that would mean getting up and walking into another room. Well, no, Roger. So we've got some dirt in the channel selector switch, which in use will sort itself out. Oh, we've got somebody. Well, isn't that as stupid? Somebody with a 5-tone Roger bleep. The very first signal we hear on this is somebody with a 5-tone Roger bleep. Are we all impressed? I doubt it. So there we have it, the Audioline 341 brought back from the dead with its defunct Roger bleep and its ridiculous 80 channel modification removed. Thanks for watching.